reference frame gives you the exact position with respect to their original orbit line.
I'll take part of all of that. So reference frame in simple words is simply a perspective. Okay. So in an aircraft, when you're analyzing an aircraft or the motion of an aircraft, in what perspective do you analyze the motion? The speed, the position, the velocity.
Are you inside the aircraft or not?
That's what, that is the question. In what perspective do you analyze the position, velocity, acceleration of an aircraft?
Observe, observe.
Right, it depends, right? It is either you can observe it from one station, you can observe it from another station, right? Depending on what control tower you're examining, or even sitting in the aircraft if you're examining, the velocity, all that changes, correct? Position, velocity, acceleration. The perspective is called the reference frame, from where you're trying to analyze your kinematics, okay? And when you attach a coordinate system to a reference frame, it becomes a reference coordinate system, okay? What is the most common coordinate system you study?
XYZ.
What is that called?
Cartesian
Coordinate system, right? That is the most common coordinate system. Can you attach any other coordinate system? You can attach cylindrical, you can attach spherical, right? So what we'll look at is, we'll look at 3 reference frames, okay, with coordinate systems attached. The first one is called right ascension and declination frame. Okay. The second one is the geocentric equatorial frame. And the third one is and just like this, perifocal or the orbit frame. Okay. So right ascension declination frame. You can refer to table or figure 4.3. Let me see if I can pull it up here. What do you need to define a coordinate system? Need an origin, okay. Okay. What else? You need, if you are defining it in Cartesian coordinates, you need at least at least two directions. Okay. And how do you identify directions? Unit vector. Or you can do it with at least two angles. Alright. Alright. So I'm referring to figure 4.3 in the textbook. Alright. So look at these. Do you understand these? What are these? What are the lines running from north to south in the figure? Longitude, right? The lines running from north to south are longitude. The lines running east to west are latitude. What is the 0 degree longitude?
That's the equator.
Longitude. Huh? The prime meridian. Where does it run through? So longitude is the line running from lines running from north to south. Okay. How many longitudes are there? How many longitudes are shown there? How many longitudes can there be?
360.
If it is divided into a degree each, right? If it is, but there can be infinite, right? If you divide it into smaller, right? So you see, the 0 degree longitude is the line running from North Pole to South Pole, passing through a place called
Greenland.
Huh?
Greenland, right?
Greenland,
Greenland, right? Is that what it is?
Greenwich.
Yeah, Greenwich, yeah, Greenwich.
So if you look at the time zone, what is it? It's generally expressed as GMT. Do you understand GMT? No? Greenwich Mean Time. So the time is referenced with respect to Greenwich. It is still referenced with respect to Greenwich, but what do we call that time zone now?
Zulu.
Zulu time. It's a more standard time, but that is where the time zone. To the east, does the sun really rise in the east? Is US really behind United Kingdom? It depends, right? But that is how we reference it. Okay? So that is the Greenwich. Now, the line passing from the center of Earth, okay, through that place, 0 degree meridian, is the lambda line. You see this? That lambda line. Okay. What is that lambda line? It's very, very important that you understand these. Get a sense of this. Okay. Everybody understands this figure? Figure 4.1? There is, how many equinoxes are there? 2 equinoxes. How many solstices? 2 solstices. Right? What is an equinox? Huh? What is an equinox? What does mean?
Sounds similar to equal.
Huh?
Sounds similar to equal.
Equal. So what is equal?
The distance between.
The day and the nights are equal.
Okay.
Got it?
So that's what the day and night.
Right. The length of the day. On the day of equinox, there are two equinoxes. Okay. There is vernal equinox and there is autumnal equinox. Put your cell phones away. Put your laptops away. Pay attention here. There is vernal equinox and then there is autumnal equinox. Okay. What is vernal equinox? When is vernal equinox?
What, spring?
The first day of the spring. Okay. So what happens on the first day of the spring?
The time, well, based on the time of January.
But
Spring forward.
naturally, what happens? The day and the night are equal. Okay. From that day forward, what starts to happen?
They started losing their equal.
The day starts becoming longer in the
Summer.
north zone.
North zone.
You have to understand that. It's not northern hemisphere. It's not the same. In the southern hemisphere, the days start becoming shorter because it's like this, right? The earth is tilted. Okay, so when the sun is at the center, this is how it is. This is the vernal equinox. Okay, so now this is the vernal equinox. If the sun is here, or if you're looking at it, it's like this. Okay, this and this is equal. Now, what happens on summer solstice? When is summer solstice? Typically, 21st June. What is the significance of summer solstice? Summer solstice.
Maximum daylight.
Maximum daylight. Okay, so that's when the northern hemisphere is completely tilted towards sun. Okay, what happens on autumnal equinox?
Like the opposite.
So this is the first day of spring. Okay, in the northern hemisphere. Got it? This is the summer solstice when the northern hemisphere has the most sun, the days the longest. This is the autumnal equinox. When is the summer season?
Is it when?
When is summer?
June to like
September.
Right? This is fall. This is summer.
that's spring, that's summer.
So this is fall. Yeah, this is this is spring. Okay. This is summer. This is fall. This is winter. That is for northern hemisphere. You get it? So you have it changes for the southern hemisphere. It's opposite for southern. What is this for southern hemisphere?
That would be fall. And then
It's winter. It's fall, right? This is winter. This is
that's spring.
spring and this is summer. You get it? So now this line is that lambda line. On the first day of spring, when the line passes, so the line passing through does this line depend on the season? This line. It doesn't depend on season, right? But on the first day of spring, this line points towards the
Sun.
not the sun. It points towards the vernal equinox. It points towards the Aries constellation. You know what Aries constellation? You know constellation? How many constellations? Aries. You know what a constellation is?
Yeah.
What is a constellation? It's a group of stars, right? How many constellations are there? Infinite, right? but we identify ourselves with 12 constellations around the equatorial region. Those are something which are very familiar to us. So the vernal equinox, if you look at the vernal equinox, the Aries constellation, this is the sign. Okay? Now this line on that day, first day of spring, this line points to the Aries constellation. Okay? In the context of right ascension declination, or in the context of what is this? This is the 0 degree longitude. Does that make sense? Okay. Right ascension. This is the right 0 degree right ascension. See if this makes sense, okay? What is ascend? Go up, right? So you do this 0 degree, okay? Where if you draw a line here, this angle is 15 degree. Okay, if you draw a line here and if you measure this angle, this will be 30 degree. So that is the longitude, the right ascension. Why the right ascension? Why it's called right ascension? Earth is rotating like this. You got it? If this is pointing in the north direction, this is the 0 degree ascension, this is the 15 degree ascension, this is the 30 degree ascension. It's in the right sense. You get it? Now, what is declination? So, what is right ascension similar to? Longitude. You got it? Right ascension is similar to longitude. Declination is what? Declination is essentially this way or this way. It's similar to latitude. You understand?
So are they actual lines on that right there?
It's imaginary.
Okay. So we
But-
can't see it in this actual picture, but it's here.
Ask the question again.
Like, where would you be able to point out the right ascension in the declination on it?
These are the right ascensions, okay? These lines.
Okay.
These are the declinations.
Alright.
I think he was asking, would you be able to point out the right ascension by actually looking at the picture?
Yeah. So what is the 0 degree right ascension? This line, okay? Get it? This line is the 0 degree right ascension. What is the 0 degree declination?
Equator.
Equator.
Okay.
Got it? So equator is the 0 degree latitude also, right? If you go up, it is 1, 2, 3, 4. How many degree latitude do you have maximum?
Oh,
90. You cannot go beyond 90. It doesn't make sense, right? You have 0 to 360. You have 0 to 360 longitude, but you have only plus 90 or minus 90 latitude. Does that make sense? Okay. So you have, what will this help you define? What is the utility of this? Anybody? Location, right? It will precisely, any location can be precisely defined with longitude and latitude. Now, how is right ascension and declination different from latitude, longitude? Even latitude, longitude are 3D. You put a celestial sphere around Earth. You can define the position of any orbiting body with right ascension and declination. Does that make sense?
No, say it again.
Latitude, longitude are limited to what?
First, sir.
Earth's surface, right? If you go beyond that, you cannot use latitude, longitude, right? Then you use right ascension declination.
And then you bring altitude into the right.
Yes. So you mention the distance, and it will tell you very specific point where that is. You got it? If you are for latitude, longitude, you don't need that because you assume that distance is
0.
the radius of Earth or altitude, right? 0, surface of Earth. But when you go beyond, you make a set of celestial sphere out of it,
Yeah.
you get
Different.
different altitude. This is what coordinate system?
Minus ascension and declination.
What? Yes. So it is a reference frame, of course, but what coordinate system? What is the basic coordinate system you have studied which applies here?
Cartesian.
Not Cartesian.
No,
This is not Cartesian. Where is Cartesian here?
See,
It's
if you have no,
it's Marcus.
Is it Cartesian? Is there XYZ?
not polar. Isn't it?
Huh?
It's not polar.
and you give me,
It's not polar, yes.
Oh, it's cylindrical?
It's spherical.
Spherical.
It's a sphere, it's spherical. So spherical, there are three, right? There is the radius, there is one angle, and then there is the other angle, right? How is a cylindrical coordinate system defined?
Four.
What are Cartesian coordinates? X, Y, Z. All three are distances. Spherical coordinate system. One is a distance, the other two are angles. Cylindrical coordinate system. Two are distances, one is angle. So you go from all distances, one angle, two distances, two angle, one distance. You get it? Angle cannot define distance. Distance cannot define it. So that's the reason.
So the two angles are right ascension
Right ascension and
and
declination.
declination.
And then you go the distance from the center, which is the altitude. So if you have this, can you define an object and an orbit?
Yeah.
Anytime, right? You use those three, you can define the object and an orbit, right? You always know this, right? You always know 0 degree latitude. With respect to that, you can define where the orbiting body is, right?
Yeah, so the latitude and longitude is only limited to like the Earth's surface?
Earth surface. Can anything orbit on Earth surface?
No.
Right. So we have to use right ascension and declination. Okay.
So does that apply to all types of orbits?
All types of orbits.
What about body?
Then you said it was a.
It's a spherical coordinate system, but it applies to orbits. Spherical coordinate system does not necessarily mean
Sphere.
it is a way of identifying the position.
How? Okay, so if it's any type of orbit, then how could it just be 3 parameters?
Can you define a spherical trajectory using a Cartesian coordinate system?
No.
You can.
yeah.
You know what
What you would have?
Can you define how do you define a circle? Can you define a circle using x square plus y square? R square is x square plus y square, right? R is equal to root of x square plus y. X square, x and y are Cartesian. If you are varying the z, you get all the sphere. You can define any in the sphere. Here you can use two angles, one distance to use to define any position. You are essentially defining the trajectory of orbit by point. Okay, it could be circle, it could be ellipse, it could be parabola, it could be hyperbola. But you are just defining a trajectory, points, the points using this point.
Okay.
How that varies with respect to time, essentially. Okay.
I understand how you find a position, but I don't necessarily understand how, looking at this reference frame, I would understand how like I guess I understood what you're saying, like how you know it would be different in spherical, like how far it would be away.
It would just
R.
it would have different
The distance R.
So there has to be an R.
Yes, there has to be R.
Okay.
So the R differs within the same orbit. It can be a little the same orbit? It doesn't have to have the same.
It has infinite range.
Okay.
The minimum will be the radius of the Earth. Okay, it has infinite range. So even in an orbit, even in a spherical orbit, or circular orbit, elliptical orbit, the R, all three are changing. Okay, in a circular orbit, R is not changing.
Yeah.
Only in R, circular orbit, R is not changing. Everything else, it is changing.
So what if we were looking at like an asteroid that's not perfectly spherical? Could we still use it?
Yeah, it's a coordinate system.
Okay.
Coordinate system is a scale. It's a ruler. It's a basis for measuring something. This is a basis for measuring. What is the basis? The basis established is 0 degree longitude or 0 degree right ascension, which is line joining the center of the Earth and the Greenwich. Okay, passing through the equator. That this direction will always remain the same. Okay. What is on this line? Greenwich. Greenwich, England. It's a place in England. Okay. So this Greenwich is on this line. Alright. So this direction will not change. You know, all of you know where equator is, right? So that is the. So if you go up, it will be positive declination. If you go below, it will be negative declination.
So the Greenwich is on the gamma line, right? Greenwich is on the gamma line, right?
Yeah.
Not on this line. It is not on the equator, of course. It is somewhere on this line up there, because England is in the northern hemisphere. Right? So somewhere 40, 50 degree. That's where. Look up the latitude longitude of Greenwich. It will be 0 plus 40, 50 or 60, something like that. You can look it up. So the other coordinate system I want you to understand here is, so here is another representation of, or another perspective of the right ascension declination. Okay, pay attention here, guys. Until you may not be able to see, move there or just come. Can you see this? What is this? Guys, no cell phones. Keep your cell phones away. This is the center of the Earth. What is this as well? Focus. It is what focus? Occupied focus. This is occupied focus. Okay. You see a satellite there?
Yes.
Yeah.
So satellite is orbiting around. Do we know what kind of orbit it is? We don't know, right? It could be circular. Can we have a spherical orbit?
Yeah.
No.
No.
Orbits are in planes. Okay, don't say yes.
Okay.
10 point, minus 10 point. So it could be in any of the conic sections. Okay. Now, can we identify the position of that orbiting body? You see R, the distance from this point to that. That is the first identification. Okay. Now you see this is the what is this? 0 degree right ascension. Right? This is, so if you have a projection of that on this plane, this is that line. You see why projection is important? Why I have been asking you to learn projections and keep it. Why I asked you to do assignment 0? Okay. So this is that projection of that line. Okay. This angle is the right ascension, and this angle is the declination. So with these three entities, you can define the position of satellite.
Which line is the projection in?
This line is a projection of this line
Okay.
onto this plane, x, y plane.
Okay.
What words. What plane
Yeah, I was
is
thinking
this?
the same thing.
Huh?
You said what?
Equatorial plane.
Constellations longitude.
Okay? So the projection of that line on the equatorial plane. So do you see the importance of light ascension declination?
Yes.
Do you see it as a spherical coordinate system? Does the orbit have to be circular?
No.
So what changes if you're orbiting like this? What changes? Does this change?
No.
This does not change. Only declination changes, right?
Yeah.
So this also changes depending on if you are in a circular orbit. This r does not change. Only the declination is changing. You understand?
There's a projection.
Yeah, projection will change. That's the reason the declination changes.
Okay.
Okay. What is the projection of here? 0. Okay. If the line is like this, if the projection, if the satellite is here, the projection is 0. Got it?
Wait a minute.
What was that?
You said
So if the satellite is orbiting like this, in a circular orbit, this does not change, only this changes. You see? This declination changes.
what you already said like the declination was from 90 to negative 90.
Right, so this is 90, and this is negative 90.
But if you want to get to the other side, don't you gotta change the ascension to get to the? You can't do an orbit if you want to do it.
Right, you're right. So in the case of, it's slightly different with regards to that, latitude, longitude. I'll give you the exact values, okay? Exact range of that values. I think it's probably minus 180 to 180. I'll look it up and let you know. But you understand this, right? Okay. Now if this becomes an elliptical orbit, what changes? R keeps on changing. You understand? And this keeps on changing. This does not change. Okay. If it is like this, everything changes. You get it? So depending on all the different orbit configurations or permutation combinations, your R changes and you are essentially defining the position of the orbiting body using a spherical coordinate system. Okay. Now here there is also geocentric equatorial frame. Alright, we understood this. Let's try to understand this. Do you see the geocentric equatorial frame? Now again I'm going to point here. This line is defined, right? Vernal equinox. We define this as the x-axis of the geocentric equatorial frame. We are going to look at, again, how do we define a coordinate system? What is the origin for both of them? Focus. Only one word. Okay, focus, right? Origin is the focus. Here we use two directions, right? Sorry, two angles for this. We're going to use two directions here. Okay? For geocentric equatorial frame. This is one direction, right? This is the x-axis or the I direction. Pretty well defined?
That's the same as geocentric equatorial.
No, the frame is not defined. This is the vernal equinox direction or the Aries direction. Okay?
So there's a point where both of them are the same, right? You're saying that the x is.
X is, for this, we have R, alpha, delta. To define, you saw that, right? R, alpha, delta. You see that there? Here it is I, J, K. Okay. This is a Cartesian coordinate system.
Oh, okay.
This is a spherical
So
coordinate.
that's just, the second one is just on Earth's surface.
I'll tell you, so I'll explain to you exactly that. Okay. This is the origin. This is one direction, x. And the other direction we define is k. What is K
Z.
or Z? Anybody?
Basically,
3
R.
words. Three words.
You asked like A.
What is Z?
It's
Celestial with top of
It's
Earth.
the zenith.
What is Z?
The radius of celestial.
I'll give you the first word. Axis.
Symmetry.
Minus 25 points because he did not think at all. He just guessed. He put 3 words together.
semi-minor axis.
The first one is axis, okay.
Oh, it's similar amount of axis.
No, axis.
The first word.
The first word is
The
axis.
second word has to be
Axis.
It's just the axis and the orbit, the satellite is orbiting.
The satellite can orbit this way as well. Satellite can orbit this way as well.
But in this case,
Huh?
It's axis of celestial.
Does it involve area?
Axis of the word of word.
Axis of definite something.
Is it? Axis of geocentricity.
Axis of rotation of Earth. Axis of rotation. It's always right-handed sense. Okay, so this is that axis. You see, guys, see here. This is that axis, right? How is Earth rotating? Now, don't open one finger. Just put this. All 3. You see, this is how Earth is rotating. If this is, this is how Earth is rotating, you put the thumb up. That thumb is axis of rotation.
which doesn't have to be Z, but in this case it's Z. Okay.
How do you express a rotation? An axis. You understand? If you are rotating, come here.
Oh man.
Come on. How do you express his rotation? How do you express mathematically? How do you express? If you define a reference frame, okay, he's rotating about the z axis. If he's rotating like this, okay, if he's rotating like this, he's rotating about negative z axis. You get it? No, not left, right. Yeah. Okay.
Can I sit back?
Yeah. All right. You get it? Understand this. This is very critical. This is mathematical. Okay. Don't do left, right-handed. I don't know. People were biased during that time, so they just did it right. But you should. Let's just follow that. Okay. Axis of rotation is expressed by the axis perpendicular to that plane. You understand? So what is this perpendicular to?
Earth
No.
surface.
Huh?
Earth surface.
Is it perpendicular to Earth's surface?
It's
At a certain point.
What is this perpendicular to?
The geocentric
Equatorial frame. Equatorial plane. Equatorial plane. You understand? What is equatorial plane? The plane perpendicular to the axis of rotation. Can you define an equatorial plane if Earth was not rotating?
Yes.
You understand? There is no equatorial plane because Earth is spherical. Only because there is a axis of rotation. What is around the equatorial plane? What has happened around the equatorial plane? There is a bulge. It's not perfectly spherical, right? So that equatorial frame happens to be the axis. It's perpendicular to the axis of rotation. You should always understand that. Otherwise, there wouldn't be any axis of rotation. If I give you a sphere, can you really tell me what plane is the equatorial plane. If it were not rotating, you cannot, right? So that axis of rotation defines the equatorial plane. You get it? So this axis of rotation is the other direction. You get it? K. You define this. You define this. What is J? J is simply K crossed with I. So if you look at J, what is J? K crossed with I. You define three directions. So what I did was I defined origin. Origin is the center of the earth or the focus. At least two directions. These are the two directions we have defined. I is the vernal equinox direction. Okay. This is the axis of rotation. 3 words. Okay. This is simply that which completes the triad. Triad, right? You need to know that what a triad is. IJK. Alright? Now with respect to this, can you define the satellite position? IJK. You can, right? You are going to say so many units in I direction, so many units in J direction, so many units in K direction. So you see that the perspective I am talking about? This is one perspective, this is another perspective. Both of these define the position of an orbiting body. Alright? And the relationship is this. What is this UR? Unit vector in the direction of, so not this. Yeah, this is the relationship. You see, these are, what are these angles? What is this angle? Right ascension. What is this angle? Declination. What is this? I direction, the I unit vector. Okay, this is how it's defined. So you can have this, or you can simply say R is equal to this, UR. Okay. So this defines the relationship. So what is more convenient for us? We understand latitude, longitude very easy. So we use right ascension declination quite a lot. Okay, and then but we cannot use that for math. So we move to something like geocentric equatorial plane with these. Okay, and this is the. So if you're given, I need you to. There is, you will have an assignment, okay? This is a special assignment. Implement
Which one was the angle for C?
algorithm 4.1 in MATLAB.
What does that do? What does that do?
That will be, get started. I won't unspecify the due date. Assignment infinity. Let's call it, yes, let me take assignment infinity, okay?
So it's never due.
Huh?
Never due.
It's never due, but it's always due.
I don't know.
Alright?
Yeah.
Any questions?
What page is this on?
Just check which page is this on.